Okay, so as promised, this time we're going to investigate how a class C is used using a default mask. And we're going to do an example where we need to identify a particular host within a particular network, identify that network, obviously, and what is the broadcast address for that particular network. So let's do it with an example. So let's say I had 192.168.10.15 as an IP address. And I've assigned that to some device. Now, one additional piece of information is you need to add a mask. Why? Because we want to make sure that the computer understands what part of this IP address represents the network and what remaining bits are left for identifying a host. So if you're going to use the default mask for class C, remember this is class C, okay? So you could use 255.255.255.0, right? So that would be the default mask for this class. Could I have used non-default masks? For example, could I have used this one, 255.255.255, and the next number would be 128. Now you're going to say, why not 1 or 2 or 3? Why is it 128? This will not be a default mask. Let me just draw a line here. This is not a default mask. This means here, if I have a class C address, it's got 4 octets, right? What I'm trying to do here is I'm trying to steal a bit from here and add it to the network identification range of bits. So I am getting into the this last octet and taking this bit here, which means everything else here is all ones. Remember, the way a mask works is that on one end you have all ones, and on one end you have all zeros. You move this line this way or that way, it's just a matter of adding more ones as you move this way, or adding more zeros as you move that way. So it's the same thing here on this particular one. So this here will not be a default mask, but it's a valid mask. We will have a lesson on other masks other than default mask. Okay, so here we're stealing a bit within that last octet to do this if we're not using a default mask. Here, if we're using a default mask, all bits in the last octet are reserved to identify the host. So we're not in this scenario. Okay, so this particular mask is called the default mask for class C because it leaves us with the last octet for identifying a host or for possible hosts that we can have. Now let's look at the scenario here. What does it mean when we add these two together? Well, one thing for sure, it's going to tell us what is the network we're dealing with. So you're going to multiply bit by bit each one of these. So 255 is basically all ones. So this octet here is all 8 ones, 8 ones, 8 ones. You're multiplying ones by 192. You're going to get 192. You're multiplying all ones by 168. Guess what you're going to get? You're going to get 168. You're multiplying all ones by 10. You're going to get that. You're multiplying 0 by 15. You're going to get 0. This will be the network address. The actual network address. This device. Remember, a device is always network and host. So it's a combination of the two. But we're interested now in the actual network. This is this network. So we know this is reserved. And since we're using a default mask, let's be clear, for this particular host, you have this network, only one network. Even though we have the possibility, if we want to, have 2 to the 24 possible networks, but this particular one is a network. So we're not looking at possibilities of networks. This is an actual network, this network. Okay, this particular networks out of possible 2 to the 24 possible networks that you could get in a Class C. But this one is a particular example. We started out with an actual IP address that was assigned to an actual device. So the key here is to identify which one is our network. So after we identify the network, we want to know the hosts, right? So possible host will be 1, .2, etc. until .254. Because the last address we're going to obtain here, .168, .10, .255, will be the broadcast. This is a broadcast address, so it's a special address. So that is why the number of possible hosts, okay, will be 2 to the 8 minus 2. And the reason we have that minus 2 is because one is reserved for the network address, the other one is reserved for the broadcast address. So that leaves us with these values right here of possible hosts. But remember, for this particular example, we already have a host identified, which is 0.15. So for this particular example, within this network, you have host 15 in there. We're not talking about 2, we're not talking about 1. These are simply possibilities. But in this particular example, the network is 192.168.10.0, so that's your network. The host, you identify it this way, 192.168.10.15. So you completely use the whole IP address to say how it's represented. Yes, it is represented as a combination of network and host, but that is your device. That is what you would put in the device, plus the subnet mask to do this. So we're going to do an example using Packet Tracer to set an IP address for a device and assign a default mask to make sure that we obtain a scenario similar to this. Okay, I will see you then for the simulation.